The present value of an ordinary annuity is calculated by the equation P equals small p for payment multiplied by the quantity 1 minus 1 plus I to the negative n over I, where the large P is the present value, the small p is the payment at the end of each period. I is the interest rate per period, which is the rate over the number of periods per year, and then n is the total number of periods. So the reason this present value formula is useful is that it tells you the amount that a person or business has to invest at the beginning in order to reach a certain goal, or it's the amount needed to cover certain payments. So example 1, what amount should you invest at 3% compounded monthly to fund monthly withdrawals of $400 for 5 years? So using this present value of an ordinary annuity equation, we are solving for large P, the present value, and we have the payment amount, which is 400. We can also calculate I, which is the annual rate of 0.03 divided by the periods per year. Since it's monthly withdrawals, then the periods per year is 12. So we calculate 0.03 over 12. 0.0025. And then last we need the n value, the total number of periods, which is the number of years, which is 5, multiplied by the periods per year, which is 12. So n is equal to 60. Then we can set up the equation. Present value is equal to the payment amount, 400, multiplied by 1 minus 1 plus I would be 1 plus 0.0025, or 1.0025, raised to the n power, which is 60, divided by I, which is, again, 0.0025. And then we calculate this in one step. One correction, it should be to the negative 60 power, because it's to the negative n power for present value. This is approximately $3,339.14. That's the amount that should be invested in order to fund these monthly withdrawals for 5 years. Example 2, find the annual payment amount to an ordinary annuity with present value $6,345 with interest rate 2% compounded annually for 12 years. So in this example, we are looking for small p. So that means we could rearrange the equation and divide both sides by this quantity to get small p for payment is equal to present value divided by 1 minus 1 plus I to the negative n over I. Or rewritten, this is present value times I over 1 minus 1 plus I to the negative n. So now we have the present value, which is P. We need I, and I is the interest rate R, which is 0.02. Compounded annually means that that's 1 time per year. So I is R over M, 0.02 over 1, which is just 0.02. Also, the number of compounding periods total is n, which is the number of years, 12, multiplied by the periods per year, which is 1, since it's annual compounding. So n is just 12. And now we have the information needed for this equation. So the payment P is equal to the present value, 6,345, multiplied by I, which is 0.02, divided by 1 minus 1 plus I, which is 1.02, raised to the n power, so raised to the 12th. And calculating this, we get approximately $600 for each payment.